and welcome back to this segment of the Reliability Matters podcast. For this quick segment, we're here with Neil Hubble. He's the president of Akrometrix. Where are you located?
We're out of Atlanta.
In hot Atlanta.
Hot Atlanta. We started at Georgia Tech about 30 years ago, so we stayed home.
Well, very good. Well, thanks for being my guest. Thank you. I think your marketing people may have said, run over there, Neil. Do it now, right?
This did get set up quickly, yes.
You've been voluntold.
Yes,
so I'm glad they voluntold you, and I'm glad you're here. Your company manufactures metrology equipment for the microelectronics world. Help my audience and me. I'll blame my audience, but help me understand. Translate all that for me. What specifically do your products do, and how do they interface in our world of electronic assembly?
Sure. Yeah, we sell 3 thermal tools and about 5 room temperature tools that use 3 different optical metrologies to measure warpage or flatness, shape of really any type of product, or to measure the expansion or the strain of those type of products. So room temperature tools for flatness and just shape and general checking. Our larger industry is the thermal side, where we're mimicking what a reflow oven does or a reliability profile would do in like automotive, what have you, to see how those surfaces might change shape as they are heated. Interesting.
So many questions just popped in my head. So this show's going to be a little bit, maybe an hour or two. No. For the measurement, for your non-thermal side, right? You're just measuring the effect maybe a thermal process had on something, or any process for that matter, weather-related, humidity, whatever causes things to change shape.
Sure, yeah.
Would that be on circuit boards, like maybe bare boards, or populated assembled boards, or components, or all of the above? Or what do you
Definitely all of the above. We're all the way from raw materials and wafer all the way to final assemblies, together. More bare boards, more components, and those that are putting them together, the contract manufacturers, where the rubber meets the road in surface mount, that's usually where most of our interaction is.
And your description is for microelectronics. Is this specifically for microelectronics? And if so, what's the difference between how your products would be implemented from microelectronics to, standard large format electronics?
I mean, we do tend to get mostly into the surface mount space. That's where we live. Have we used it for anything and everything? We've measured refractory bricks and paper and heat sinks and metal. Sure, anything that needs to be flat theoretically.
So your definition of microelectronics is surface mount, a small component, miniaturized components, as opposed to other electromechanical assemblies or something else.
Right. Yeah. Semiconductor industry.
Right. Yes. Okay.
Yeah.
All right. Just so we're on the same page. So you make equipment that measures that. What would be a common cause that would result in something warping or something coming out of tolerance? I think of maybe a board going through an oven, and it could bend and all. But are there some unusual causes, or are there poster child causes that cause people to even have to get equipment from you to check?
Sure. Well, first of all, they all move. It's just how much, right? People ask if something is flat. Nothing is flat to us in our world at our resolutions.
You're looking too closely, right?
Yeah. I mean, sure, it's not going to be really flat, but is it flat enough, right? So the common driver is CTE mismatch, so coefficient of thermal expansion, how much something expands.
Yeah, something's moving this much, something's moving this much, and
if they're attached together,
someone loses.
Right, yeah. If you have on the package side, if you have a die and you have a redistribution layer, those have very different expansion characteristics. Someone loses, and a lot of that comes out in Z movement. So it plays a lot into, say, board design and copper balancing. We had a paper here at this show about how copper distribution and different material choices can affect the shape of local attach areas on a board.
Are there, in the board design world, they all go by design rules. Are there design rules that help minimize the TC differences and all that?
I think there's minimal, honestly. I mean, I think that's one of the challenges, right? Is process? Process to design.
Your next generation of customers.
Right. Yeah. That communication between process and design. It's not always the first thing on the design list, but those process engineers, certainly, try to push on when they can in that area.
And is the use of your products? I'm assuming the use of your products is not once everything is established and procedures are made and protocols are followed, is it more on the within the design stage when to test out the design, or is it also used in production as a, every once in a while we test something?
Yeah.
Or is it done when a oh shoot moment occurs?
Yeah. All of the above, all of the above. I mean, we started more failure analysis, more oh shoot moments, and we do contract testing, and a lot of those are that, oh shoot, I got a problem, come to us. What are more established customers, it's more part of their NPI, it's part of their process when they're doing early design, material choices, vendor choices, they're using that as part of their evaluation and setting in a product. And then a lot of them now are using it as purely a quality control. So a lot of your mobile packaging, they're doing lot sampling for everything they make just to make sure the process stays and holds.
Yeah, nothing changed.
Yeah, so it used to be failure analysis. Now you have three of ours.
Now it's QA.
Yeah, now it's QA. Now it's a lot of QA. So you might have 3 systems lined up running 3 shifts, just doing lot sampling, doing QA, and doing volume. And our tools can test multiple things at once, and it's all very fast. Allowing for that.
So that's the segment of your business that tests after something's been made. It sounds like you also have the thermal side, which maybe allows you to force something to happen, almost like a halt test, where you're just bringing something to the point of where its tolerance ends. That's your thermal testing. You're trying to bend stuff, and you're trying to
a lot of that
stuff.
Quality is really on the thermal side. Yeah. So it's okay. What is this going to do when I put it in my oven?
Right.
So we're mimicking everything that's going to happen in a reflow oven, and seeing when my solder solidifies.
So it's not like a failure test. You're not pushing it past its limit.
No, we're not looking for failure.
We're simply mimicking a way where they don't actually have to build entire assemblies or whatever in order to see. You're simulating the environment that would otherwise may lead to a failure.
Yeah, and simulating is one of those words that sometimes people go in the wrong direction with our stuff, because we're physically, we like to say emulating. It reminds people that no, we're actually physically doing time and temperature.
That's true.
That's going to happen in production because matching to like an FEA model is a common use of our products as well, right? They're going to check modeling against practical, and we would be the practical for that.
Right. And are your customers, do they fall into a specific group like Class 3, IPC Class 3, high reliability assemblers, or Class 1 consumer stuff, automotive stuff? I mean, are there certain industries and types of products that tend to care more about expansion and warping and things like that?
It is really very broad. It's definitely not just high reliability. Because you're thinking about some of the volume manufacturers that are just trying to push yield.
Right.
I mean, difference between 0.5% and 1%.
Cell phone manufacturers, right?
Yeah, huge in the cell phone side. So miniaturization is a big need for this. But also on the other end, some of the larger stuff, like trying to put down a very large BGA, for instance, onto a large board. That's a whole different challenge, that we're seeing, and that's one of the biggest trends we see is a lot of the big stuff in the AI side and all the data you got to collect now. Those are difficult things to assemble. Just the physical challenge of a component that's very large is quite a challenge for our customer base.
Yeah. We're now competing with the announcement being made. So I'm going to, are we hearing that, Summer? Okay, they're done. I never like to compete with the PA system.
Understood.
One last question, and forgive the ignorance of this, but I can see your product is probably used obviously in the design phase and in the production phase, testing, et cetera. Is it ever used in the field phase? I can see, with electronics, with IoT in particular, with electronics frequently going out into harsh environments, whether it's in space or aerospace, where it's going into an unpressurized section of the aircraft and exposed to wild temperature swings, or it's going downhole in Houston, exposed to high thermals. Are there any testing protocols that you're aware of that will run a product for 6 months and then pull out of the field and test it to see if if expansion and contraction and warping occurs not just during the manufacturing process, but in the in-use climactic environment?
Yeah, I mean, honestly, not that much. No, I mean, we do, however,
so things stay.
Yeah. I mean,
once they survive manufacturing,
But
they
that
say.
reliability side is a factor for us, because you
Right.
might do like advanced thermal cycling and spend a lot of time trying
Okay.
to learn
Little
that
time machine.
Right. Yeah. Trying to figure out how many failures you're going to have, how long it's going to take. What we would do is do that same thermal excursion a couple of times, and we've done studies, with people who have done the advanced thermal cycling work, and you can kind of map some of those failures to the warpage behavior. So okay,
Right.
this corner has a lot of shape change from -40 to 100C. Well, that's also the corner that starts failing first after a couple of months,
Right.
in the cycling. So reliability testing in the subroom and the automotive is a pretty large area for us.
Interesting. And you had a good show?
Yeah, solid. Yeah.
Excellent, excellent. Well, Neil Hubble, President, Akrometrix, thank you so much for the impromptu interview and being a good sport and being my guest today.
I appreciate it, Mike.
All
Thank
right.
you.
Good meeting you.
The Arch FX manufacturing platform. Processing over 1 trillion data points each month. Bringing value to every level of your organization. That's manufacturing insights for tomorrow.